Let's look at composition of functions. For example, let g of x equal x plus 2 divided by x plus 1 and h of x equal to 2x plus 5. Let's find g composed with h and state its domain. Now this composition is defined as follows. G composed with h of x is equal to g of h of x. But h of x is 2x plus 5. Therefore, this is equal to g of 2x plus 5. And what is g of any input? Well, we take this input and we plug it in wherever we see an x here. That is, this is equal to 2x plus 5 plus 2 divided by 2x plus 5 plus 1, or 2x plus 7 divided by 2x plus 6, which would be our composition we're looking for. Now we're also asked to state its domain. So let's begin by looking at this final form here. The only issue would be if x were equal to -3, because then we'd be dividing by 0. So we need to exclude x equal to -3 from the domain. So the domain of this final form here would be the interval from -infinity up to -3, open parenthesis because we do not want to include -3, union, again, open parenthesis at -3 up to infinity. However, when finding the domain of a composition, not only do we have to look at this final form, but also x has to be in the domain of this inside function, h. But looking at our function h, the domain of h is all reals. So all of these values here then are fine. That is, this would be the domain of g composed with h. All right, let's look at another example. Let f of x equal the square root of 9 minus x and g of x equal x squared. Let's find the composition in both directions, f composed with g and g composed with f, and then we'll state their domains. All right, let's start with f composed with g. So f composed with g of x, by definition, is f of g of x. But g of x is this x squared, which means this is equal to f of x squared. And what is f of any input? We take that input and we plug it in here where we see an x. That is, this is equal to the square root of 9 minus x squared. All right, looking at this final form here, what is the domain of this final form? Well, what's under the square root, namely 9 minus x squared, has to be greater than or equal to 0, which means that x squared has to be less than or equal to 9, which means that -3 has to be less than or equal to x, has to be less than or equal to 3. So the domain of our final form here would be the interval from -3 to 3. Any of these values would be fine to plug into this square root here. But remember, whatever x we're plugging in up here means we have to plug it in into the inside function. So not only do we look at the final form, but we also have to make sure that x is in the domain of G. But again, the domain of G here is all real numbers. Therefore, any of these values down here in this interval are fine to plug into G. So this is the domain of F composed with G. All right, what about the other direction? What is G composed with F of x? This is equal to G of F of x. And F of x is this square root of 9 minus x. And G of any input is that input squared, which is equal to 9 minus x. Now looking at this final form here, the domain would be all reals, wouldn't it? However, remember, whatever we're plugging into this composition has to be in the domain of the inside function. And looking back over here on the left, what is the domain of f? We need 9 minus x to be greater than or equal to 0, or x to be less than or equal to 9. Which means we need to exclude any real number that doesn't satisfy this inequality. That is, the domain of G composed with F is the interval from -infinity up to 9. And this is how we work with compositions and their domains. Thank you, and we'll see you next time.